Welcome. We'll get started here in just a moment. All right. Cool. So today we're talking about Python code samples for OpenUSD. This is a project that I helped work on at NVIDIA, and the result of it was this list here of code samples that we shared. And so for every code sample, we talk about some topic, some function, something that you might want to do, um, and break down the concept a little bit, explain what's going on here, and um, and then show different flavors of the code sample. So if you're working in Omniverse, you can do this with Git commands. So let's talk about how you can do it that way. Or if you're using just the vanilla USD Python API, here's how you would do it. And so we released this about a year ago, and it's been pretty useful. Uh, and we added a few here and there, but it's time to improve this and make it even better. I think we can keep improving this and making it more useful for everyone. So one of the things that I've been working on with a few other people at NVIDIA is um, just kind of trying to standardize these samples to make them easier to learn with, easier to just copy paste into your own code. So that's what we're working on. This is a working session. This is work that I'm trying to get out, and but I thought it'd be useful to share what I'm doing and talk through it and um, and maybe learn something along the way. Because I'll definitely be learning a bit here um, as I go along. You'll see that it's a little involved here with what we're wanting to do. So let's jump over to VS Code. If you're here, let me know. Say hi. Welcome, Zion Sky. Also, I need to get, hold on, sorry, this open and this open. All right. So here's the repository. Here's our source code for the code samples. And here's an example of what we want to get to. This is all broken out into smaller files to kind of modularize this into something that we can build out into whatever we want. And if I open one of these, let's see here. Let me show you one in progress here so you can get an idea of what we're working towards, if I remember how to get there. Whoops. Come on. Okay. And then paste this over here. So here's an example of kind of what we'd like to get to. We've got tabs for different flavors now. USDA output when it makes sense. If you're authoring something, it'd be nice to see what the end result may look like in USDA format. But as far as the actual code sample and the work that I'll be doing today, I want to take the actual relevant code block that actually does the work and wrap that up into a function. And what that does for us when we consume this is one, if you're brand new and you're learning and you don't know what camera.define returns, or for example, in the previous iteration of this, uh, I might be using a stage. I don't want to define a stage every time, um, but I assume that you have a stage that you're working with, and so in the previous iteration of this, I wonder if we can actually see it. I had this, right? Just a variable called stage, and you just had to know that was a stage. So by wrapping this up in a function, we get it's very and using type hinting for the parameters, we get there's no doubt what all of these variables are, um, and then also a return type for this function. The other nice thing about wrapping this up in a function is that now it's somewhat testable, right? We have this is runnable code, whereas what we had before was not runnable. This is undefined, and we can't test it. So uh, those are the main benefits of going with this approach. And then the other feedback that we got is, well, if I'm brand new to to USD, um, this is great. I might find this and I say, okay, I need to create a perspective camera. Here's the code that I need for it. But I might be so new that I don't know where I'm supposed to use this in context. So we also want to add um, this full usage section after. So if you're pretty aware of what you're doing, you just grab this code here, paste it into wherever you're working, and you're good. But we wanted to make this more of a learning content. So um, when you create, when we also want to add this full usage where we use this function in context. So there's going to be all this scaffolding and boilerplate code for using it, but for some people it'll be useful. Um, so creating a stage, setting a default prim, that's just good practice. Um, and then calling the function, you get the camera back. What can you do with the camera? Well, let's go ahead and print out the stage first, just to see what the result was, right? So that's you get some output like this, and then let's do some things with that camera that was returned, just to get an idea of once I've created the camera, what can I do with it? So that's kind of the motivation here is to provide some context, some more kind of bookend that learning experience for folks. So that's what we're going to work on. If you have any questions, let me know. Otherwise, we'll jump right into it. So we have at least a few of these converted already. So I showed you that perspective camera. I'm just going to start going down the list and modifying these. Cool. So that one's done. Let's check orthographic. I don't remember where I left off here. This one looks good. I need some more asserts here. So I already did this for the perspective camera, and the orthographic camera should be pretty similar. So I'll just copy this over. And then the nice thing about doing these asserts is it kind of also tests the code. So I think testing is something that automated testing is something that's going to kind of evolve over time. We don't want to hold people back from creating samples because maybe they don't want to create tests. So just doing these little asserts here will go a long way towards giving us some confidence in what we're doing, and that these samples will be useful and will work for folks. Cool. So pretty good. Just checking to make sure that the path that it was created at it was created where we expected, that it's a camera type, and that the projection in this case is orthographic. So that one looks pretty good. I like doing these big old blocks of comment here so that you know what you're getting into. Would this be used in Blender? Yeah, actually. I think Blender has the USD API available. At least the one from, I don't have it installed, but the one from the Omniverse launcher, I'm pretty sure you could get access to that. Otherwise, if it's not, you could always do pip install USD core and probably get it that way. So yep, that should be useful to you. Cool. Okay, commands here. I did the validation here, so that's good. Be good to space this out a bit more just to. Cool. 2 down. This one is convert VT array to NumPy. So this one's really useful if you're working with big arrays in USD and in Python. You may need to edit those arrays. For example, the points of a mesh. You may want to write some code that like deforms it or manipulates those points. In which case, converting to NumPy will let you vectorize those operations on the array, and it'll be a lot faster in Python than doing like a for loop on this array here. So being able to convert to and from NumPy is really useful. All right, so now we got some real work here. So def convert. We're converting this one is converting VT array to NumPy. No, you'd want to do if you're trying to install USD Core in Blender. I don't remember. You need to be using you need to grab the Python interpreter from the Python exe from Blender and use that to install it. So you wouldn't do it in VS Code. You would do it. I'm sure there's tutorials and examples out there for how to do it for Blender. But a quick test that I would do first is just do like from Pixar import USD and check if that works in Blender first. So, all right, this one is good. VT array to NumPy array. Something like that. Do I need to pass anything in? VT vec. And this could be any array. It doesn't have to be vector 3. So look at that in a minute. Anybody know how to do? I should learn how to do proper type hinting in Python. I told you this was going to be a learning moment for me. Python type hinting multiple. I think it's like union. But I want to do, there's like an arbitrary number of different types that you could do. I don't want to do any because that's kind of lazy. If anybody knows, let me know. Blah, blah, blah. I wonder, or maybe I use the base class. I think there's a VT array base class. Ask GPT. I don't have it set up right now. I don't want to. VT array. And I don't have, I should probably install USD core in here so that I get proper. Why? That I did that right. But maybe there isn't one built for this version of Python. It is. I did it right. I don't know. Oh, that's probably why. That is why. So I'm using Python 3.11.4 and USD core is only built for 3.10 and lower. I'm not going to go through that right now. The other thing that we have here, what I can do is maybe find the documentation. VT. So is there a base class? Maybe not. Yeah, see, I'm not going to list all these types. All of these types are actually acceptable for that function. I started with the hardest one. Let's do this. We'll leave that. I'll come back to it. And then I'm going to copy this over. We're going to use this in our full usage. Okay. So we're going to make a vec3 array, and I guess we can just return it. Or it's kind of, yeah, we'll just return it. Cool. Cool. And then let's do some stuff with this. And the other thing I need to do is pull up code, because we're gonna make sure these scripts work. Hot loading preview. If we're talking about for the code sample, no, I have to build it right now. But yeah, clarify on what you mean by the hot reload preview. Window script editor. Cool. So we got the NumPy array. What can we do with the NumPy array just to show that all of this is working? Also, I should probably print out VT just to see what else we can do with that. Maybe there is a base class that I can use. Yeah, so for what I'm doing today, really this is just Sphinx documentation. I do believe there is a auto rebuild for Sphinx. I just don't use it enough to really leverage that right now. But for code that we write for Omniverse, the USD code that we write for actual production, real work, there is hot reloading. blah, blah, blah. So there's no, it doesn't look like there's an array base class exposed in Python for the NumPy array. Maybe what we can do is definitely check the length of it. So we can do something like np array.size. Yeah, so the total size is 9. What if I want just the 3 elements? What does the length return? Three. Okay, cool. So that may be sufficient. Assert. Nine. Assert length of np array is equal to 3. Anything else that we could do that might be interesting for somebody that doesn't know? Some. Nah, I think that's fine. Cool, cool. All right, now we got to do the other one. Make sure I know what I'm doing here. NumPy ND array was the actual type. Cool. And then this other variation is to convert the opposite way. So and this one's even trickier, right? Because when it returns, it could be anything depending on. Oh no, I see. So I'll need to I could make this sample a lot better. Because really I only ever showed one type. But I'm just gonna call this vec3f array. I know these names aren't great, but maybe I should just call it VT to NP. Better. And then this one will be NP to VT. Cool. So that's gonna return that one. So now create the array. Let's do our full usage business here. And then we do the conversion. And then I'll need to see what I can do with the VT array. Here we go. And then let's try this one. So from NumPy variable can do what? It's got some cool built-in functions. We can definitely get the length of it. And I think that might be all that we're going to do here. Okay. Check it one more time before we move on. Run successfully. Lovely. And that's it for that one. I could maybe make this a little bit better here. Right in the headers. And then we can just add a little note here. Ref. And we'll link to this again. Cool. And yeah, we can build this to see what this looks like. There we go. And I got a typo. All right. Nice. These are easy. Um, so I just want to make sure I got my imports right here. I didn't check that earlier. That looks right. I think technically you want two lines there. Okay, so here we're going to probably import at the very least USD, and then we're going to pass in the stage, and we're going to get a list of USD. I'm going to do this the older way. Oh, and we need a name. Return found prims. Okay. For this, we need to do some building here. So, because we need to have a stage with interesting data to be able to traverse. So I'm just going to copy paste this bit. We're going to need from Pixar import USD geom and SDF. And then we're going to create some shapes here. USD geom, xform, define. We're going to call this world group, and it's going to want the stage. And then world cube. Group cube, and then let's do a sphere just for good measure here. Or actually, we should give something. So that's a cube. That's a cone. And that's a sphere. It doesn't really matter what types they are, but it's better if they're all different for this example. Now I can call my handy dandy function. And we want to find all the foos. Okay, so we should get a list of 2 prims. And then prims list USD prim. Okay, and now we can do some interesting asserts. Assert prims dot length of prims should be equal to 2, and prims 0 at name would be equal to foo, and assert prims 0 is instance of USD prim. Okay, I think that should be good. So now we can copy all of this and try it out. And it worked. That looks right. I guess I could do, no, that's fine. gonna say I could check the paths of these, but I don't care too much about that. Okay, so another one down. I think we can do one more, and then I gotta go. Um, Anybody want to see a specific one, or should I continue down the list? Next one is by type, so it's going to be pretty similar. Feel pretty good about this one. Either. You got it, Zion. All right. We're going to do the find by type. So we can basically copy paste a bunch of stuff, and hopefully I don't mess up, don't make any clerical errors when I'm doing this. So we need this stuff here. See this one, this sample could be better now. Find prims by type. I don't know how to specify. Blah, blah, blah. Come on. So I could do. Okay, we can do this. Stretching myself here with these type hints. Type. This is kind of a stretch here. It's a USD object or USD. Will that work? Yeah. Okay. I think that'll work. I think that's basically every schema class inherits from typed, I think. And we can confirm that before I go. USD geom mesh, for example. All of these inherit from USD typed. So I think that'll do it. Type var. I think that's fine. List of USD prims, still good. Okay. So this one was a little bit trickier than I thought because we had to do some work to adapt it to be more generalized. So we're looking for meshes this time. So let's do a couple. Instead of foo and foo, we'll do mesh here, mesh there. Foo bar baz. And then we find them by type. We pass in the stage. And we use USD geom mesh. Find prims of type USD geom mesh. Cool. So I should still get to see now these are going to be, and this is going to be an instance of mesh, but then I can do prim0 get type name. Let's be a little bit nicer here. And the type name will be mesh. Okay, so I think that should do it. Let's try it out. No errors. Oops. Come on. I don't know why I put first name. I meant to say first prim. But for now, we'll use first name. So there's bar. I know these asserts are checking this for me, but I don't trust myself. All right, so we're good. We have two of them. They're USD prim objects, and they have the type name mesh. So I guess what I could do is let's do this for prim in prims. It should be an instance of that. I think that's how you do it. And there. I think that one's nicer. Cool. Now we're checking all of them just as a sanity check. Okay. We are at the top of the hour. Got a few done. Pretty happy. Any questions before I go? Can be about what we worked on or not. Just keep in mind we only have like a few minutes because I do have to run to a meeting. All right, so hopefully I'm gonna keep cranking away at this, and hopefully we can get these out to you all, and they'll be better and more useful, and help more people learn how to use USD. Thanks for coming. I hope you guys have a great week. And yeah, I'll see you guys around. Tomorrow we have sorry, one last thing. Tomorrow we have a really great live stream with Damien and Jen about building Kit apps in Kit 105. Um, so come around for that. That starts at 11 a.m. Pacific here on these channels. So hope you can make it, and I think it'll be a really great session. All right, see y'all. Bye.